What if I told you that time moves slower for astronauts in space than for us on Earth? Welcome to the mind-bending world of Einstein's theory of relativity. In the next, we'll explore how time, space, and gravity are not what they seem. Buckle up. In 1905, Albert Einstein published his theory of special relativity. The key idea? The laws of physics are the same for everyone, everywhere, and the speed of light is constant. Imagine you're in a spaceship moving close to the speed of light. To you, time feels normal. But to someone watching from Earth, your clock ticks slower. This is called time dilation. Even distances shrink. This is called length contraction. It's not sci-fi, it's proven. GPS satellites must account for these effects to give us accurate locations. 10 years later, Einstein expanded his theory to include gravity and created general relativity. Gravity isn't a force pulling us down. Instead, massive objects like Earth bend the fabric of space-time, like a bowling ball on a trampoline. The stronger the gravity, the slower time moves. This is why clocks on mountaintops tick slightly faster than those at sea level. Relativity helps us understand black holes, the expansion of the universe, and even time travel. Near a black hole, time nearly stops. Astronauts in Interstellar weren't just dramatizing, they were experiencing time dilation due to intense gravity. Einstein redefined how we see the universe, not as a static backdrop, but as a dynamic stage where time and space bend and dance. Let us know in the comments, what part of relativity blows your mind the most?